All right, so as you guys can see here, again, just some quick updates. Don't forget, we've got the new, we've got the notebook checks all set up online for you guys to take pictures of your notes and send it. So please complete that before the end of the week. Weather maps and scripts need to be completed as well. I've got several zeros on those, so if you want to get rid of those zeros, get those completed. And we've also got the test happening in the form of quizzes for us throughout the week. Again, quizzes will be occurring for us throughout the week. So we will get things going from there on that front. Okay. Let's take a look at numbers 1 and 2. It says right here, list the tropical events from weakest to strongest on page 24. So you got to know those. And then number 2, what are the wind ranges of the following? Depression, storms, and hurricanes. So if you guys have any input on those, I'll give you 10 seconds to add to the chat. Otherwise, we'll lead the way because we did not have any in-person students last week. So I'm going to lead the way on that if you haven't already. Okay. Anybody? Angel, are you all ready to go, Angel? Okay. So let's go ahead and move on to number 1. The list from weakest to strongest is going to be disturbance, okay, depression, tropical storm, and then a hurricane. So these are essentially the different stages that a hurricane grows and develops in. Okay, so the baby hurricane is going to be the disturbance, right? Elementary level is going to be the depression. Okay, it's going to get more rain, more circulation. Maybe the high school level is the tropical storm, and then the fully grown adult storm is a hurricane. Okay. Next, let's talk about how they differ in their winds. Obviously, the winds get lower the farther down you go. The farther up you go, they get stronger. So for our depression, it's going to be a maximum of 38 miles per hour. So if it goes above that, it's then going to move on to a storm. The maximum wind for a storm for number 2, letter B, is going to be 73 miles per hour. Okay, so up to 73 miles per hour is a tropical storm. And then as you guys can automatically assume, if it's above that, it's going to then be a hurricane, which can reach up to 155 plus miles per hour. So 74 to 155 plus is going to be your maximum range for a hurricane, right? Hurricanes. Okay. Angel, did you know what has faster wind speeds, hurricanes or tornadoes? Tornadoes, yeah. But hurricanes are much more what than tornadoes? They're larger, they cover more area, right? So hurricanes, tornadoes, they're both really bad. They're just different, right? They both cause a lot of damage. They're just different. Any questions on that? We all got that. Again, feel free to take pictures if I go too fast. Otherwise, I'm going to go at the pace that my in-person students are at. Okay, moving on, guys. Go ahead. We're not going to worry about these writing questions because we're going to have all multiple choice. I'm doing things a little different for our class, so no need to worry about these. Update, if you want to go and update the last page of the table of contents, you can. Page, we can just change it and make 22 to 24 like tropical events, and then 26 red tides and red algae. We'll do that tomorrow, I'm thinking. Okay. So we'll go from there a little bit. And when my in-person students are ready, we will go ahead and do our first practice question of the day. And for all of you online, please be ready to answer this question in the chat. One second. This one should hopefully be easy for you guys. Okay. Let's see here. All right, and as soon as my in-person students are ready, we will move on. Looks like they're ready to go. All right, here's our first question of the day. Oh, the website. My website's been a little, the Plickers website for the questions has been a little not the best. Okay, here we go, it's working. All right, so go ahead and tell me which tornado classification is the weakest. Again, which tornado classification is weakest? Is it A, F5, B, F3, C, F0, or D, F1? Please answer in the chat. Answer in the chat. Let's see. Irina, Lakia, Sanaya, Tatiana, Yorkies, Daniela, Joseph, Amira. Please answer the question in the chat. Good job, Angel. Got it right. Again, what is the weakest tornado category? I have nobody answer. Please answer. Please answer. All right. Thank you, Irina. Great job, Irina. Thank you, Joseph. What is the weakest category? Lakia, Yorkies, thank you. Amira, thank you. Need some more people. Need some more people. Tatiana, thank you. All right. So shout outs to Tatiana, Diego, Amira, Yorkies, Lakia, Irina, and Angel. The correct answer is indeed going to be F0. F0 is the weakest category, the weakest classification for tornadoes. Again, for hurricanes and tornadoes, just know the lower the number, the weaker the storm, the higher the number, the stronger the storm. Okay, let's go to move on to our tropical storm, tropical events notes from last time. Again, for my online students, I'm just going to cross off things as much as I can to make it short for you guys, right? And if my in-person, just go to where it says hurricane right there, the third section, just write down what's in red. Okay, so what do we need to get a hurricane, guys? Again, take pictures or whatever I cross off, don't write, right? And then you just ignore the cross-offs, Angel, because you'll need to write what's in red. So in order for something to be a hurricane, now we're going to keep this. It's got to be a tropical cyclone with a maximum sustained speed that exceeds 74 miles per hour. So I'm going to give that a check mark. We're going to keep that. That's a good one to write down. We need that. Highly defined I, okay? So if it doesn't have an I, it's going to end up being a tropical storm, right? If it doesn't have an I, it's going to be a tropical storm, okay? And then if you haven't heard of typhoons and cyclones, those are actually the same exact thing as a hurricane, okay? They're just in different oceans. So typhoons are in the Pacific and cyclones are in the Indian Ocean, okay? So that's for hurricanes. So let's just write hurricanes there. Again, this is on page 23. Again, we are writing this, continuing it on page 23. Give you a moment to take a picture if need be. Otherwise, you can get it at a later time. Okay. And we're going to go ahead. I forgot to show video question. We have our first video question of the day, so let's go ahead and check that out. Okay, and our video questions include, number one, please write this down on page 23. Where do hurricanes start? I want us to know where exactly do hurricanes come from in the entire globe, right? Where do they start out at? And then number two, what is the most violent part of the hurricane? Is it the outer bands? Is it the eye of the hurricane, or is it around the eye? What part of the hurricane is the worst part of it? What part of the hurricane is the worst? Take a moment and see what you guys think. Okay, and when my in-person students are ready, we'll begin. We'll check out our first video of the day. Kind of keeping things bouncing around a little bit, going from one thing to the next, not doing the same thing for more than 5 minutes, right? Again, if anyone has any questions or issues, please let me know in the chat. All right, Angel, you're all set? Okay, let's check out our first video, guys. Again, number one, where do hurricanes start? Keep in mind, number one happens pretty quickly. They mention it at the very beginning, I think in the first 10, 15 seconds. And then number two, what part of the hurricane is the most violent and worst part of the storm? Let's check it out. And some more commercials, my bad.
The most destructive hurricanes that make landfall in the U.S. start as a group of thunderstorms moving west off the west coast of Africa.
There you go, let's hear that.
Some of the most destructive hurricanes that make landfall in the U.S. start as a group of thunderstorms moving west off the west coast of Africa.
There we go. You heard it first. That's number one.
This group of storms feeds off the warmth and moisture of the ocean. Air rises then to form more storms and is replaced constantly by the surrounding air. Below all this air rising, low pressure develops. Riding along the trade winds and rotating counterclockwise, thanks to the Coriolis effect, a result of the Earth's rotation, the storm will keep growing as long as it has these key ingredients. Water temperatures at or above 79 degrees. Ocean water versus land. Hurricanes don't like land. They need open water to survive. And
so keep in mind, again, land is what makes hurricanes a lot weaker. It cuts off their life source. Hurricanes need warm water to survive. Warm water keeps hurricanes growing stronger. Land makes hurricanes get a lot weaker. Here's number two. Number two's coming up.
High pressure above it. Weak flow, or what we call a lack of vertical wind shear above a hurricane, is vital to keep it intensifying. Now let's talk about the eye of the hurricane. Always impressive from space. It forms as air rotates up and out of this hurricane. Now, some of the air that's being spit out at the top of the storm then sinks back into the center, keeping the eye itself relatively calm and clear. Immediately surrounding this tranquil eye is the most violent part of the hurricane, the eye wall. The most intense wind speeds at the surface are found right here in the eye wall, but they can extend, of course, out from the storm's center. The most destruction in a hurricane comes from the eye wall out to the right quadrant. So you take the already impressive wind speeds inside the hurricane, add the forward motion and the storm surge, and you have a recipe for disaster.
All right, so pretty straightforward there. A great short breakdown of our hurricane stuff. Number one, Angel, where do hurricanes typically start? Yes, off the west coast of Africa, specifically all the way across the Atlantic Ocean is where they'll begin as regular thunderstorms off the coastline. And then what part of the storm is the worst? The eye wall. So the eye is actually going to be very calm and nice, but shortly after that, you get the very worst part of it, which is what's around the eye. Eye wall is the worst of the storm. So when you're in the eye, you're only safe momentarily, and then you'll be in the worst part of it. So not necessarily safe, as you guys can see there. Again, the eye wall is the worst part. Warm ocean waters off the west coast of Africa. Any questions on that? Take a picture now if you'd like. We're going to go back to our hurricane sheet to look at the different different levels of the hurricane categories. Let's go take a look at that. Okay, so let's move on to this, guys. All I want you to do is I just want you to write down these categories. Okay, and you'll see them listed there for you as well, Angel. So again, we got to know this, the miles per hour and the categories, right? So all this is good stuff. It's nothing too crazy. Okay. 2, 3, right? 4. I mean, all of it, right? All of it. It's all good. We got to know the mile per hours, right? You don't need to memorize these, but just understand there's categories. I think on a test, I'll give you a diagram that'll say like, second, it'll give you like the numbers, and then you can figure out, what category it is. But again, 1 to 2, bad but not terrible. 3 to 5 are really bad. They can do a lot of damage. Keep in mind, Hurricane Irma. Angel, do you remember when Hurricane Irma was here? What category it came here as?
4.
No, it actually was a 1. Hurricane Irma, when it got to the Caribbean, was a 5 and a 4. But when it landed in Tampa, all those islands made it a lot weaker, which made it a category 1 by the time it got here to Tampa. So let's take a look at, make sure again, so we got those categories, 1, 2, 3, 4, 5. Again, starts at 74 miles per hour and goes up all the way up to 156. Keep in mind, guys, tornadoes get up to like 250. So tornadoes still, even though they're a lot smaller, tornadoes still are faster in wind speed. Okay. Any questions on those? Any questions on those? All right, let's take a look at those categories illustrated by our next video. Pretty cool stuff here. And see what those are like in our simulation. And then later, I will show you real life footage. Or commercial. Sorry about that. Okay, no question, just watching.
Each one's impact.
different hurricane
When it comes
categories.
to hurricanes, each one's impacts are a little bit different, but the wind speeds that we talk about along the Saffir-Simpson scale, those are very specific. And the damage caused in those categories, kind of predictable. So let me show you. Let's start off with a Category 1 storm. And the damage here, not too bad. A couple of shingles fall off, you can have some palm fronds bending in the wind, but everything basically remains intact. Category 2, that's where you really start to feel it. Look at the windows of the house. They can be hit from debris from the outside and already start breaking in a Category 2. Your trees are significantly bent over in the wind, and the siding of the house itself can break, flapping there in the wind, adding to those eerie noises inside. Category 3. I've heard only a Category 3, but it's not only anything except really bad news. In a Category 3, you can have the door of the house blown in because the winds get so strong. You can have the roof of the house start to flap up and down in the wind because it can lift off those weak points, and a lot of those trees start to fall. Category 4, the damage is even worse. You get most trees falling, most of your windows breaking, most of your shingles fly away, and then Cat 5 is as high as the category scale goes. By Cat 5, no shingles remain anywhere nearby. The holes in the roof get so big that the walls of the house start to fall because they're not attached to anything anymore. There won't be any trees up in the neighborhood. That's just catastrophic damage. But again, that's just from the wind, and there are other impacts from hurricanes, and they all vary through the season. So stick with the Weather Channel to keep you safe when the tropics head towards your neck of the woods.
All right, so we can clearly see there again, half your house being basically destroyed, roofs being taken out when it gets up to those 150 mile per hour winds for the Category 5 storm. So pretty scary stuff there. Why we always got to remain safe and cautious about these storms. Let's go move on here and take a look at our next thing. I'm going to show you some real footage. For you guys online, I'm not going to have you write this out. You got the wind speed, you got the damage. For my in-person dudes, you can have it just have it down just in case. But we already got this. We're good. What I would just write is like storm surge. Maybe write about storm surge a little bit. But I'm not gonna. You know what? I'm just not gonna make you write this whole chart out. I'm not gonna worry about it. Just know it gets worse the farther down you go. Now, for my in-person students, you can write that down just because you're able to get it down. But I would just focus on, you got these already, so you're good. Again, the higher the number, the worse the hurricane is. But just keep in mind, storm surge, it gets worse. That's when the wind pushes the water higher levels and it makes it flood everything. That's a big problem, right? Problem right there. I'm gonna see if I can write the word problem. And we will move on with our, how bad my handwriting is. No, not terrible. Not terrible, right? So this is the big problem, is the storm surge. Okay, let's move on and check out some real footage, not just a simulation of Category 5 winds in action on this beach area. I think it was up in the Panhandle like years back. They had a really bad hurricane, Hurricane Michael, I think it was. This one.
File with the help of an expert.
Oh, more commercials. I guess you just gotta. Okay. What is this? This is not. Oh, it's another commercial. All right, so let's take a look here at this house. Check out the ceiling. Just completely Category 5 winds. Look at the roof there. And it's going to be taken up like it's a piece of paper. Walls being pushed down, more rooftops being taken out. Again, same thing. Category 4 or 5. Walls, concrete walls being taken down. All right, so you guys get the idea. Pretty intense stuff. Okay, so let's move on then again to our next section regarding a hurricane formation. Okay, so we go to the top of the back side of our sheet there for my in-person students, And then for my online students, let's take a look here. What do we want to include? 1 second. Where's my pen at? My pen. There we go. Okay. So yeah, this is pretty much the key things, right? Require 2 items for formation. I will need that. Okay, we'll need that. Hurricane formation. Lots of warm water. And this one's it's so short. I'm like, why not just keep it all? Okay. So your 2 main ingredients to get a hurricane. There's two ingredients. We see them right here. Okay. We see warm water and lift. Okay. So if I got warm water, because Angel, what does warm water do very easily? What is it we call it when water turns into a gas? Yeah. If the water is warm, as Angel just said, it can evaporate really easily, which means all that water vapor is going to build up that hurricane really nicely. Okay. And then all we need is air to lift all that moisture up. That's going to make a hurricane. That's going to make a hurricane or tropical storm or what have you, right? So take a moment for that picture. Or if you write fast, no problem there. Okay, we'll move on here in a second. Okay, so let's do maybe our last question of the day. Again, please answer in the chat when you are ready. And I will show you my question when I'm ready. All right, 1 second, guys. Last one of the day. That should be a good question. Really get us ready here. Give me one moment. Okay, this will be a tougher question than the first one. If you guys want help on it, the answer's on page 19. The answer's on page 19 where it's lightning. You're going to use the lightning diagram. You're going to use the lightning diagram. 1 second, guys. Okay, here we go. This is going to be, okay. Here's our last question before we finish up here. Which answer correctly describes lightning charge setup? Is it positive, negative, negative from the cloud top to the ground? Is it positive, negative, positive, negative, positive, negative, or negative, positive, positive? That's the diagram on page 19. Diagram on page 19. See what you got. See what you got. Answer in the chat. What is the correct setup of lightning? Okay, thank you, Lakia. Thank you, Irina. All right. Still need more people. I need Tatiana. Need Diego, Amira, Yorkies, Joseph, Irina. Oh, I got you, Irina. Never mind. Okay, do about 10 seconds. 5-10 seconds. Probably the last question of the day. Okay, I want to give shout outs to, let's see here. I think shout outs to Tatiana and Lakia. All right, and Yorkie, shout outs to you as well. Okay, answer is going to actually be letter B. Letter B, guys. It's going to be positive at the top of the cloud. It's going to be negative at the bottom of the cloud and then positive on the ground. Again, the ground is positive. The ground is positive. Okay, so that's the lightning charge setup we must know. Keep that in mind for future test questions, maybe our quiz questions coming up. Okay, moving on here, guys. I think this is the last thing of the day we're going to write. Okay, so for my in-person students, we'll get that down as it says up here. For my online students, and this is a lot, maybe too much for us to write. So let's see. We're just going to say warm air absorbs moisture. Okay, warm air absorbs moisture. Okay, water vapor is lifted. We'll just cross up into the atmosphere. Okay, so warm air absorbs the moisture. The water vapor gets lifted. Okay. We'll say as the cooler upper air condenses it. So Again, as the water vapor rises, the cooler up air condenses it into liquid droplets. Okay, so it's going to form those clouds, make those dense hurricane clouds. Water vapor, we have lift. Okay, and then we're just going to say for 4, condensation is just going to release a bunch of energy. It's going to swirl up that storm, make it stronger and tougher. Okay, and then lastly, okay, moist air, we'll say creates a wind current. Okay. So just so it's a lot less for you guys to write, we'll just say again, warm air is going to be absorbing moisture. The moisture gets lifted up. Okay, that moisture, those warm water particles are going to cool down into a massive hurricane cloud, and then they condense, releasing energy, and it's going to create wind, and it's going to spin it. That's how we get a hurricane. That's how we're going to get a hurricane. Before we call it a day, let's go ahead and take a look at one last video, kind of all about Hurricane 101. Just so you guys can see this, if you were to be walking around in a Category 2 hurricane, this is what essentially it would look like. Okay, so just to walk around in 109 miles per hour, that's a Category 2. This is what it looks like. Again, this guy's on top of a mountain, so it's a little different, but he's trying to sit down, and the wind is so strong that look at that, just falls over. That's just a Category 2. Imagine a 5 or a 4. Okay, barely able to walk here. Okay, so pretty cool stuff. That's just Category 2. What would be like in a 5? Okay, and let's finish today with our last video clip about Hurricanes 101, just to sum up everything we talked about today.
Cyclone, typhoon, hurricane. All of these names are used around the world to describe the most powerful storm known to man. Hurricanes are unpredictable, but scientists have a thorough understanding of how hurricanes form and sustain their power. In the Atlantic Ocean, hurricane season peaks during the late summer months when tropical waters are the warmest. Hurricanes form from a cluster of thunderstorms that suck up the warm, moist air and move it high into Earth's atmosphere.
Yeah, we have the moist air, the warm air, and then it's going to condense and cool it down, right?
The warm air is then converted into energy that powers the hurricane's circular winds. These winds spin around a low-pressure center called the eye, which can provide a 20 to 30-mile radius of eerie calm. Encircling it is the eye wall, a towering ring of clouds with some of the fastest wind speeds of the hurricane. Surrounding the eye wall are curved bands of clouds, the rain bands, often tens of miles wide, releasing sheets of rain and sometimes tornadoes.
And don't forget again, what's the worst part of a hurricane? The eye wall. The calmest part is the eye.
When a tropical storm's winds reach at least 74 miles per hour, it becomes a hurricane. The hurricane then receives a category ranking of 1 to 5 on the Saffir-Simpson scale, based on its wind speed and potential damage.
Was that right?
But wind speed isn't always the most dangerous component when hurricanes come near land.
Storm surge.
It's storm surge. Storm surge is caused when winds from an approaching hurricane push water towards the shoreline up to 20 feet above sea level and can extend 100 miles. 90% of all hurricane deaths are the result of storm surge. While hurricanes can cause mass devastation, just like other natural disasters, they serve a higher purpose within the global ecosystem. Hurricanes help regulate our climate by moving heat energy from the equator to the poles, keeping the Earth's temperature stable. Over time, science has helped us to better understand hurricanes and predict their paths.
So just to save you time, just wanted to give us a rundown there of hurricane formation and also hurricane damage. let's go ahead and just as a reminder, again, don't sign out just yet. We've got the, just as a reminder, guys, we've got the notebook checks to complete. We've got the weather scripts, the weather maps. So make sure we're all getting those things done and turned in because the quarter ends in a month. Progress reports are coming out. So that is that. Let me go ahead and 1 second.